Hello Harsh, how are you?
Fine, sir. How are you?
I'm also fine. So we have discussed that in the like this in this type of circuit, when the wire is same, the charge is same. When
Mhm.
there are different wires, then charge will distribute accordingly. But when you can say here you are moving like this, and in your path, if there is capacitance or resistance, then there will be potential drop. Otherwise, the potential will remain same. So
Same.
our topic is the series combination of capacitor. Series combination of capacitor. Series combination of capacitors. Series combination of capacitor. So series combination of capacitor looks like this. When you connect the negative plate of the capacitor with the positive plate, this is the series combination of capacitor. Suppose I am connecting only 4 capacitors here. Okay, we can connect n number of capacitors. So like this, n number of capacitors are connected in series, and this is the battery here. This is the battery, and this battery has a voltage V. So this is the positive terminal, this is negative terminal. So this terminal is positive, then this terminal is positive, and this is negative.
Yes,
This is
sir.
this is negative, and this is negative. Then this is positive.
Positive.
This is negative. Means in the series combination, capacitors are connected with opposite charge plate. Like positive plate will be connected to negative plate. So this is just a different thing. And suppose the capacitance of this capacitor is C1, this has C2, this has C3, C4, and accordingly this has capacitance Cn. Capacitance Cn. And we know that if Q charge is flowing, then the wire is same, there is no branching, then Q charge will flow here. Here also the charge is Q. Here also the charge is Q. Here also the charge is Q. Means in all the capacitors, across all the capacitors, the charge will remain same. If I am saying charge across capacitor 1, charge across capacitor 1, that is equal to Q1, and Q1 is equal to Q. Accordingly, I can say Q2 is
Yes,
equal
sir.
to Q,
Yes, sir.
equal to Q3, and so on, equal to Q1. Charge across capacitor is Q1, Q2 is charge across capacitor Q2. Q2 is charge, you can write here, across C2. Charge across C2. But we know that here here will be here is now potential V. You are moving like this, like this, like this, and now here is the capacitor. Here is a capacitor. So now the potential will drop here. Potential will drop here, and I am assuming the voltage across C1 is V1, C2 is V2, because why the potential is different across C1, C2, because there are capacitor in the path. Here is potential V3, not potential, voltage V3, here is voltage V4, and here is voltage Vn accordingly. I can write this V is divided like V1 plus V2 plus V3 plus V4 plus Vn. So I can write V is equal to, this V is equal to V1 plus V2 plus V3 plus V4 plus Vn. And what is V1? V1 is the voltage across. V1 is
Capacitor.
voltage across C1. Accordingly, you can say V2. So now what I am doing, I am replacing these all the capacitor with a single capacitor, single equivalent capacitor, single equivalent capacitor. Now I have replaced all the capacitor with single equivalent capacitor, and this is the voltage V and charge flowing is Q, and we know that charge is same. So this is C equivalent, this is C equivalent, and from here I can write, from here I can, we know that V is equal to Q by C. This V is equal to charge upon
Yes, sir. Charge
capacitance,
upon capacitance.
capacitance, charge upon capacitance.
Capacitance.
And if I want to find V1 here, value of V1 is equal to C1 by Q1.
Yes, sir.
If I want to find V1, V1 is equal to Q1 divided by C1. Q1 is Q divided by C1.
C1.
And if I want to find V2, V2 is equal to Q2 divided by C2. And Q2 is again Q divided by C2. And accordingly, you can find V2, V3, and for Qn, I will write Q by Cn. Now I am putting value of this value here, this value here. This is C equivalent. This is C equivalent. This is the equation 1. This is the equation 1. Now put value of V1 here, value of V2 here, value of V3 here, and value of V here. So value of V is Q divided by C equivalent, and this is V1. V1 is equal to Q by C1. This is Q by C2. This is Q by C3. And you can add all the capacitors. Q by Cn. Now from here, this Q is cancelled out from everywhere. So we have the equivalent capacitance 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3, and accordingly 1 upon Cn. So in the series combination, the equivalent capacitance is calculated like this. In the
Series
series.
combination.
Yeah. So now if I want to find the total voltage across the circuit. If I, number 1, in the series combination, if I want to find the total voltage across the circuit, okay. So total voltage, I am representing total voltage with Vt. So what is the value of Vt is equal to V. Here you can see the total voltage is V. Total voltage here is V. Now if I want to find the total charge, total charge, that is Q. And if you want to find Q, then we have the formula Q is equal to C equivalent. We will take the equivalent capacitance this time into V. And third, if I want to find the voltage across each capacitor, voltage across each capacitor, voltage across capacitor 1 is V1. V1 is equal to Q by C1. Because charge remains same, then we can put the value of Q1, Q2, Q3 as Q. This is C2. And accordingly, you can find for nth capacitor. This is the voltage across nth capacitor. So here you can write Q by Cn. And if I want to find the energy stored in each capacitor, the amount of energy stored in each capacitor. Energy stored in each capacitor. And we know that energy is a scalar quantity. So we have the formula of energy like Q square. If I want to find energy stored in capacitor 1, I will write U1 is equal to Q1 square Y, 2 times of C1, but Q1 is equal to Q. So I am writing Q1 as Q square. This will become 2C1. So U1 is equal to Q square divided by 2C1. So accordingly, I can write U2 is equal to Q square divided by 2C2. And I can write for nth capacitor Un is equal to Q square divided by 2 terms of C. And if I want to find the total energy stored in the circuit, total energy stored, so total energy I am representing with capital U suffix T, and this is the sum of all the energy because we can add the energies because energy is a scalar quantity. So U1 plus U2 plus U3 plus and so on. And there is one more way to find the energy. If you want to find the total energy, so you can write charge is same. So Q square divided by 2 times of right here C equivalent. So in this way also you can find the total energy, or in this way also you can find the total. So Harsh, please note it down.
Yes, sir.
So do you have any doubt? And you can ask me if you have any doubt. It's very
No,
easy.
sir. No, sir. No doubts.
Because see here, charge is same because the wire is same. I have
Yeah, it's
told
in
you earlier.
series combination.
There is
Yes, sir. There is
there are
no branches.
yeah, and potential difference is here changing because in the path we have this capacitance. Due to this,
Capacitors.
please note it out.
Sir, can you scroll down? I've noted down till capacitor, change across capacitor. Yeah, sir. From there, after it.
Yeah, na?
Yeah.
Okay, you can note it down.
So can you scroll down? Sir, a little bit up.
What?
A little
If I
bit up, sir.
a little bit
Scroll.
up.
Yeah, that's it. Thank you, sir.
Okay, fine. This is total voltage. Total.
So can I scroll down? So can you scroll down?
Okay. Mm, now it's fine.
Yes, sir.
So energy is stored in each capacitor. Is we know the formula of energy, Q square divided by. We have three formulas.
Yes,
So
sir.
I am using Q square by 2C1. Q square by 2C because charge is same here. That's
Yes,
why I
sir.
am using this formula. You can use other two formulas also. There is no problem.
Like half CV square.
Yeah, half CV square you can use.
Okay, done, sir. So just one. Last line. Done, sir.
Now we will solve very simple one very simple question. This is the capacitor and this is the capacitor. These capacitors are connected in series on the same wire, means they are on series. So here is capacitor of capacitance 5 microfarad. Here is a capacitor of 10 microfarad. And here is voltage, here is 10 volts. 10 volts voltage is there. This is C1, this is C2. And before that, I want to add one thing. For that, I want to add one thing. Like if two capacitors are connected like this is just for two capacitors connected in series combination with a battery or a cell. So this is C1, suppose this is C2. And if you want to find the equivalent, so what you will do? You will find C equivalent is equal to 1 upon C1 plus 1 upon C2. And when you will solve this, you will get C equivalent is equal to C1 into C2 divided
C2,
by C1 plus C2. And
C2. Yes.
you should remember this formula. We will use this. You should remember
Yes,
this.
sir.
For the two capacitors connected in series, the formula is C1 C2 divided by C1 plus C2. And here we will use this. So in this question, we have to find hmm, calculate number one, C equivalent. You can say equivalent capacitance. Equivalent capacitance. Number second, you have to find total voltage.
Okay.
Number third, total voltage means total voltage of circuit. Charge stored in each capacitor. Charge stored in each capacitor. Fourth is voltage across each capacitor. Voltage across each capacitor. Fifth is total charge. Sixth is energy stored in each capacitor. Energy stored in each capacitor. And seventh, the last part of the question is total energy stored. Total energy stored. Okay, see this figure and we will use this here. Mm,
So just want to write the question.
do you want to note it down?
Yes, sir. I'm writing the question, sir.
Okay, fine. Please note.
Yes, sir, you can continue.
So the first part is to calculate the C equivalent. We have this figure. We have this. And first part is to calculate the equivalent capacitance. Answer first. What is the formula of C equivalent?
Sir, C1, C.
Yeah, you can use that also, but I am just
Sir, 1
writing.
by C1 plus 1 by C2.
Yeah.
Because series
And
is there.
yeah, this is series combination. This is series
Yes, sir.
combination. This is series combination. So C equivalent from here you can get. You can use this formula directly. C1 C2 divided by C1 plus C2, and the value of C1 is 5 microfarad. 5 microfarad. You have to convert microfarad into farad. So
Yes,
one,
sir.
one
Minus
micro
raised to 3.
minus 8 over 6.
6.
6.
Yeah.
Milli is for 10 to the power minus 10 to the power minus 3 is for milli.
Yeah, it's micro.
Like you can say 1 microfarad is equal to 10 to the power minus 6 farad.
6 farad.
1 millifarad is equal to
10 to
the
the power minus
power.
3 farad.
So this is 10 into 10 to the power minus 6.
6.
And you can write here. Actually, we can do one thing more. Okay, we can write this also. So here I am writing 5 into 10 to the power minus 6 plus 10.
10 into 10 to the power minus 6.
Now take common 10 to the power minus 6 here. Not here. Here, what is the value? 10 into 5, 50.
50.
Into 10 to the power minus 6
minus
into 10
6.
to the power minus 6. And from here, 10 to the power minus 6 is common. 10 to the power minus 6 is common. So here, here is 5, here is 10.
15.
So 5 plus 10, 10, 15. So 10 to the power, this is 10 to the power minus 6. Now 10 to the power minus 6 gone with 10 to the power minus 6 somewhere. And now we have 50 by 15. 50 by 15. So I can divide it with 5. 5 tens are 15 and 5 tens are 50. 5 threes are 15. This will become 10 to the power 3 and this is 10 to the power minus 6 farad. So you have this C equivalent. And you can write C equivalent as, you can also write this is 10 by 3 microfarad, you can say.
Yes, sir.
Depending upon the examiner, what he want to ask. If he is asking the answer is microfarad, you should write the answer is in microfarad. If he wants the answer in SI unit, then you should write the answer in farad. So we have calculated the C equivalent. We have calculated the C equivalent. This is C equivalent. The first part of the question is completed. Now second part is total voltage. We have to find the total voltage. We have to find the
total voltage.
Total voltage. I represent total voltage with V suffix T, and total voltage is nothing but, what is the total voltage? You can see in the circuit 10 volts.
Yes, sir.
Total voltage is 10 volts. Second part is also complete. Now see the third part. Charge stored in each capacitor.
Oh, 5 microfarad.
Yeah, charge stored in each capacitor. But for the charge, first we have to calculate the no, charge stored in each capacitor. Okay, so we can use third part, charge stored in each capacitor. Here you see here, total charge is also Q,
Yes, sir.
and charge stored in C1 is will be also Q. Means charge is Q always. Charge is Q. Means total charge is also Q, and charge on each capacitor is also Q, because this is the series combination. So I can, if I want to calculate the total charge, that is I am representing with QT. Total charge is equal to Q, and Q we know that C equivalent into V. I can write, what is C equivalent? 10 by 3
10 by 3, yes.
into 10 to the power
Into
minus
10
6
minus 6
into
into
10.
10
So this will become 100 by 3
into
into
10
10
to minus 6
minus 6, and unit of charge is coulomb.
coulomb.
Okay.
Yes, sir.
So this is the total charge, and if I want to find the charge across C1, the value is same.
Yes, sir.
The value is same if I want to, because same charge is flowing across this and across this. So we have now the fourth part of the question. Uh, uh, charge stored in
Voltage.
charge stored in each capacitor. Charge stored in each capacitor means they are asking Q1. Q1 is equal to Q2, and that is equal to Q total,
Yes, sir.
and that is equal to Q, and that is equal to 100 by 3 into 10 to the power minus 6 coulomb. Or you
Yes.
can write this, 100 by 3 microcoulomb.
Yes, sir.
Micro. This is the third part. Now fourth part. Voltage across each capacitor. Voltage across each capacitor means V1, V2, V3. Voltage across each capacitor. V1 and V2 we have to find. And voltage is different in series combination. Why? Because when you are moving from here to here, there is something in the path. There is capacitor in the path, and there will be the voltage drop. Due to this, there will be the different voltage of this and this. So for the voltage V1, if I want to calculate, V1 is equal to Q1 by C1, and the value of Q1 is this. The value of Q1 is this. This is 100 by 3 into 10 to the power minus 6, and value of C1 is 5 into 10 to the
5
power
into 10 to the minus 6.
minus 6, and minus 6 and minus 6 gone with minus 6 somewhere. So this will become 100 by and you can divide this also. 5, this will become 2.
50.
No,
Oh, sorry. No, yeah, 20,
yeah.
20, yeah.
20. So the answer will become 20 by 3 volts.
Yes, sir.
20 by 3.
Yes, sir.
Volts.
So it will be 6 point. We should write in
No.
points?
Oh, you can write like this also. 6.67, that is okay. You can write in this form. This form is also correct. I want to calculate V2. V2 is equal to
Q2 by
by
C2.
C2, and Q2 is again 100 by 3 into 10 to the power minus 6, and C2 is 10 into 10 to the power minus 6. Now 10 to the power minus 6, 10 to the power minus 6, this will become 10 tenza, this will become 10 by 3 volts. 10 by 3 volts. Now I am checking whether this is correct. We have total voltage. Can I write total voltage as V1 plus V2?
Yes.
So V1 is 20 by 3 and V2 is 10 by 3. The LCM of this is 3. This will become 20 plus 10. This will become 30 by 3. So total voltage was what we have the total voltage calculated earlier, 10 volts. Means this is correct.
Yes, sir.
I have just cross-checked. So this is the fourth part now. We have to calculate the fifth part. Total charge. Total charge is again same. Total charge. This is the fifth part. What is the total charge? We have already calculated the total charge here. 100 by 3 into, and I am again calculating. Right? If you want to calculate the total charge, then you have to write the total capacitance, means equivalent capacitance into voltage, total voltage. So total charge, if you want to calculate, then this is C equivalent, it is 100 by what is the value of C equivalent? Equivalent
Sir,
is 10 by 3 into
10 by 3.
10 by 3 into 10 to the power minus 6. I am just calculating this again. We have already calculated this. So this will become 100 divided by 3 into 10 to the power minus 6 farad. Or you can write this 100 by 3 microfarad. No, not farad, this is coulomb. 100 by 3 micro coulomb. Fifth part is completed. Now sixth part. Energy stored in each capacitor. Energy stored in each capacitor means energy is stored in
Half
5
CV
micro.
square. Yeah.
You can use any formula, half CV square, or you can use Q square by 2C depending upon you. So you can write sixth part. U1 is the energy stored in capacitor 1. You can use half C1 into V1 square.
Yes, sir.
So this is half. Value of C1 is 5 into 10 to
5
the
into
power,
10 raised to minus 6.
and you have to put the value of V1. V1 is equal to 20 by 3.
3.
20 by 3 volt square. 20 by 3 square. So this will become half into 5 into 10 to the power minus 6. The square
Into
of
40
20.
by 6. 40 by 9.
No,
400 by
14,
9. 400 by
400 by
9. Yeah, it is
So
20.
from here you can calculate. This will become 2000 and this will become when you will divide this will become 1000. This will become 1000. You will divide this with this, so
Yes,
this
sir.
will become 1000, and here is 5 in multiplication, and here is 9, and we have 10 to the power minus 6 also. So the answer is 500 by 9 into 10 to the power minus 6 joule.
Yes, sir. Joule.
The unit of energy is joule.
Joule.
And you can also write this as 500 by 9 microjoule. 500 by 9. So this is the energy stored in capacitor 1. Now energy stored in capacitor 2. Half C2 into V2 square. C2 is 10 into 10 to the power minus 6. And V2 is 10 by 3 square. So this will become half into 10 into 10 to the power minus 6, and this will become 100 divided by 3. Now from here you can do this. This will 500 by 3. No, this will become 9. This will become This is 5,000 here. This is 5,000.
Yes, sir.
This is 5,000 and this will become, this is cancel out with this 500 by 9
Sir, in 10 to the power minus 6.
into 10 to the power minus
6.
6 joule. Hmm. And last part of the question is total energy. Total energy, for the total energy, you can add both the energies either, or you can use the formula.
Again, half CV square.
This is the seventh part, no? Seventh part total energy.
Yes, sir.
Seventh part. Total energy we have to find. So for the total energy, either you can write half, for the total energy, half, either you can write half C equivalent into V square.
Yes,
Either
sir.
you should use this half C equivalent into V square, or you can also use Q square divided by 2 times of C equivalent.
Yes, sir.
Or you can add, if you want to, if you don't want to use the formula, you can do like this also. You can add the energy like U1 plus U2 with this also, or and I am just finding this energy is half C equivalent into V square, total voltage square. So the value of C equivalent is 10 by 3.
Yes, sir.
See here, 10 by 3 microfarad. 10 by 3 microfarad means 10 by 3 into 10 to the power minus 6. And V square means 10 square. Vt, total voltage is 10 square, then this will become half into 10 divided by 3 into 10 to the power 6 into, this will become 100. This will become 100. So this will become 500 by 3. 500 by 3 into 10 to the power 6 joule. Okay. See here the energy. Here 500 by 9. When you will calculate this value and this value, you will get this answer also. So you can
Yes, sir.
do in the way you want. So please note it down. This is the question. From here you want to
Sir, done,
write
sir.
down.
I already noted it down.
You have already written.
Yes.
What, very good. Okay. So now we have parallel combination. And in parallel combination, I have told you the voltage across each capacitor remains same. Is same. Like parallel combination of capacitors. Parallel combination of capacitors. Parallel combination of capacitors. So see here how the parallel combination looks like. I'm just connecting only 3 capacitors. You can connect n number of capacitors here. For the simplicity, I am just connecting 3. So this is C1, C2, C3. And see here, this is the positive terminal, this is a negative terminal. So this is positive, this is positive, this is positive. So this means this is positive, this is positive, this is positive, and this is negative, this is negative, this is negative. So you can say positive terminal of the capacitor is connected with positive terminal in the parallel combination. The
Yes, sir.
positive, not the positive, I am saying the terminal. Positive plate of the capacitor is connected to the positive plate, and negative plate of the capacitor is connected to the negative plate. So this is the parallel combination, and we know one more thing. The potential difference across C1, across C2, across C3 will be same. We have discussed. Okay, no problem. So see here, from here to here, when you are moving here to here, suppose this is point A. Suppose this is point A, okay, and this is point B. From here to here, here is potential A. Here also the potential will be VA.
Yes, sir.
Here also the potential will be VA because there is no capacitance and resistance in between the path. And here is the potential
VB.
VB, V suffix V. So V1 is the voltage across C1, and V1 is equal to V2 minus, oh sorry, VA minus VB. If I want to find V2, then I can write VA minus VB. For V3, VA minus VB. So see here, the potential difference across each capacitor is same in the parallel combination. And this is the voltage battery of voltage V volts. And if I want to find V1, then I can write Q1 by C1. And now see here, see here. What about the charge? If Q is the total charge flowing, this charge will be flowing like this. But from here, there is branching. There are branches. So
Yes, sir.
here is charge Q1. Here is charge
Q2.
Q3 and Q2.
Yeah,
Accordingly.
Q3 and then Q2.
Q2, Q3, and so in the capacitor, for the capacitor C1, the charge is Q1. So here charge is different. Means charge is dividing. So for the charge you can write Q. This is total charge, and this is dividing like this: Q1 plus Q2 plus Q3. I am just connecting here these three capacitors. You can all connect n number of capacitors. This is the total charge. Now what I am doing, this is the equation 1. You can write. Now what I am doing, I am replacing this whole combination of three parallel capacitors with one equivalent capacitor. So here we have now this C equivalent, and here is the battery of V volts, and here charge is Q. So can I write Q is equal to C equivalent into V? Can I write this now? Can I write this? And one thing more you can see here. V1 is equal to V now. V1 is the voltage is same. This V is across C1. This V is across C2. This V is across C3. So from here you can also write one thing. V1 is equal to V2 is equal to V3 is equal to V, the total voltage of the battery. So now in equation 1, and from here if I want to calculate the charge, I want to calculate Q1. Q1, what is Q1 is equal to C1 into V1.
Yes, sir.
And what is V1? V1 is equal to V.
Yes.
So C1V. So accordingly, I can write Q2 is equal to C2V. Q3 is equal to C3V. So you can put value of Q1, Q2, Q3 in equation 1 and value of Q in equation 1. Where you will put, you will get the answer like you have Q is equal to Q1 plus Q2 plus Q3, and the Q is C equivalent into V. Q is C equivalent into V, and Q1 is C1V, Q2 is C2V, and Q3 is C3 into V. Now you can take common V from this. This is C equivalent into V. So V is common here. Here is C1 plus C2 plus C3. So V is gone with V somewhere.
Yes, sir.
So you can write the formula C equivalent in the parallel combination C1 plus C2
C2
plus
plus C3.
C3. If you have n number of capacitors, so you can write C1 plus C2 plus C3 plus and so on plus Cn.
Cn.
So we will add directly the value of capacitance in the parallel combination. There will be a chapter current electricity. In that chapter, resistance will be added
Yes,
in
sir.
series and parallel,
R1 plus R2 plus R3. Yes, sir.
but the story is different there.
Yeah, in parallel is 1 by R1 plus 1 by R2 plus 1 by R3. Series is R1 plus R2 plus R3.
So have you noted, or do you want to note it down?
No, sir. I have to note this.
Okay, so please note. You have to identify the difference between the parallel and the series combination. In the series combination, the capacitors are connected on the same wire. There are no branching. And if there are no branching, then charge is same across each capacitor. But in case of parallel combination, there are branches of wire. So total charge is divided across each capacitor.
Yes, sir.
This is the difference in the circuit. I am coming in 1 minute. Okay, 1 or 2 minutes.
Yes, sir. Sir. Second scroll down.
Have
Second
you
scroll
written
down.
this? Okay.
Yes, sir. So down, sir.
Oh, sorry. From here, no?
Sir, no, sir, down. From parallel combination.
This is a parallel combination. What are you saying?
Yeah, now it's okay, sir. Before it was on the question.
No, I have not given any question on the parallel
No,
combination, right?
the series combination question. It was on the screen was on that.
What are you saying?
Before you were scrolling this, the screen was on series combination question. That's
I know. Okay, please note it down. From here. From here you want to know?
Yes, sir.
So in the series combination, the charge across each capacitor is same. But in parallel combination, the voltage or you can say the potential difference is same across
Same.
each capacitor.
Second scroll down.
So I have just replaced all the capacitor with this single equivalent capacitor.
Yes, sir.
Because I want to find the equivalent capacitance of the network, of the circuit. We have one more circuit in movie.
Second scroll down.
Okay.
Done, sir.
So now, as in the previous case, we have calculated the total voltage, total charge, total energy across each capacitor. We will calculate all those things. So first is if I want the total voltage. Total voltage across the circuit, you see here, total voltage is V. Again, V is total voltage.
Yes, sir.
Vt. Total voltage is V. And total charge, if I want to calculate total charge we have Q, and we have Q is equal to charge across, okay, Q1 Q2 plus Q3, capacitor 1, capacitor 2, capacitor 3. And for this charge I can also write C equivalent into V.
Yes, sir.
So that for the total charge I can write this formula. If I want to find the charge stored in each capacitor. Charge stored in each capacitor. Charge stored in each capacitor. So see here, that's in this circuit, in this combination. Here Q1 is charged in the capacitor. So
Yes.
I can write Q1 is equal to C1 into V because potential is same, because voltage is same, Q1. So I can write Q1 is equal to C1 into V1, and C1 is C1 and V1 is V. So Q1 is equal to C1 into V
V.
and Q2 is equal to
C2 into V.
C2 into V. And but in case of series combination, you can see in the series combination, you have the charge like this. In the series combination, you have written the charge. Charge is same in the series combination.
Yes,
Okay,
sir.
you have just written Q in Q1 and Q2. If you are calculating Q1 and Q2, then you have written just Q. In this question, you can see here. Total charge. See here, Q1 is equal to Q2 is equal to Q. Total charge in the series combination, but in the parallel combination, we have some different formula. So charge stored in each capacitor is like this, and if n number of capacitors are connected, then you can say for n number of capacitors connected in parallel. So you can write Q n is equal to C n, but here the voltage will always remain same in the parallel combination. Now, if I want to find the voltage across each capacitor, voltage across each capacitor. अरे यार ये क्या हुआ?
Sir, can you hear me?
Yeah.
Sir, was I
So
disconnected?
what?
Was I disconnected?
Actually, there is a power cut here. So now you can
Okay.
see. Now you can see. Now I want to find the voltage across each capacitor. Okay, voltage across each capacitor. So here the voltage is same.
Yes, sir.
Voltage is same, na? See.
Yes, sir. Voltage same, sir. C Q C1.
V1, V2, V3.
Yeah,
V1,
yeah.
V2, V3 is equal to V. Like I want to find V1 is equal to V2. This is equal to V3. This is equal to V. For n number of capacitor, we can say Vn is equal to V. Means If you are connecting three capacitors in parallel, then the voltage is same. Again, when you are
Yes, sir.
connecting n number of capacitors, then again the voltage remains same. So this is the, now I am calculating the energy stored in each capacitor. Energy stored in each capacitor. Fifth point is energy stored in each capacitor. Energy stored in each capacitor, we have three formulas. So I am using this formula, half C1 into V1 square. Half C1 into V1 square. And C1 is C1 and V1 is equal to V. So for the energy, you can say U2, if you will calculate, the value will become half C2 and voltage is same. For n number of capacitors, if you have, then you can write energy stored in nth capacitor is equal to, you can say, Un is equal to half into Cn into V square. Why I am writing V same? Because voltage is same across each capacitor. So if you want to calculate the total energy, if you want to calculate the total energy, so Harsh, now please tell me how we will calculate the total energy
Total
stored.
energy.
Yeah,
Sir, it will be
it will
half
be.
C square, right?
But you instead of C, you will put you have to put C equivalent.
Yes, the total, of course, C equivalent.
Give me just 1 minute. I am connecting with my Wi-Fi.
Yes, sir.
So total energy stored. So Harsh, total for the total energy, we can write simply. First, we can calculate the total energy with this U1 plus U2 plus U3. Energy in capacitor 1, energy in capacitor 2, and accordingly you can calculate.
Yes, sir.
And one more formula for calculating the total energy is equal to half. You will use not C, you will use
C
C, you will
equivalent.
use equivalent, and voltage is same.
Yes, sir.
So this is the formula for total energy. The formula for total energy. Have you written or?
Sir, can you move to the sixth point, sir?
Okay,
The last point actually you wrote. Yeah, this one, yeah. Right.
please write.
Done, sir. The
So
chapter is
we
over, right?
have, after that we have some numericals, and there is one more topic, like when we will fill the single capacitor with dielectrics along the area, in the area, and with respect to the area and with respect to distance, and then the chapter is finished, and after that we have very easy chapter, current electricity.
Okay, sir.
Yeah. So now here you have two capacitors connected. This is the parallel combination or series combination?
Parallel, sir.
Yeah. Parallel because you
There is
can
branching, sir.
see
A
from
single wire get connection to two, and then
yeah. There are number of ways to find. Here this
yes,
is
sir.
positive plate, this is positive plate, this is positive plate. Means positive plate is connected to positive plate and negative plate is connected to negative plate.
Negative plate.
Yeah. This have a capacitance of 10 microfarad. 10 microfarad, and this have a capacitance of 5 microfarad, and this is C1 and this is C2, and suppose C1. We have to find, and here is a 10-volt battery again. 10 volts battery, and we have to calculate this time C equivalent and total charge after that we have total charge across each
Sir, you're
capacitor.
lagging, sir.
Lagging?
Yes, sir.
My voice is lagging. Okay, give me 1 minute. Hello, now it's okay. Now it's okay.
Yes, sir. Now it's okay.
So charge stored in each capacitor. Charge stored in each capacitor. Fourth is voltage across each capacitor.
Yes, sir.
And one, two, three, four. Fifth point is total charge. Total charge we have charge stored in each capacitor, voltage in each capacitor. Total voltage sixth question is energy stored in each capacitor, and total energy stored in the circuit, or you can say no, in the circuit. So this is the figure, this is the diagram. And we have to find, for the first part, we have to find for the first part you have to find C equivalent, and C equivalent is simply in the parallel combination C1 plus C2.
Yes, sir.
And the C1 is 5 plus 10. This will become 15 microfarad, and we can convert this into the farad, 10 to the power minus 6 farad. So C equivalent is equal to 15 into 10 to the power minus 6 farad. This was the first part. For the second part, total charge we have to find, total charge. So for the total charge, you can, from here, charge, total charge, this is the total charge, and this charge will flow like this. Here is Q, and this Q will be divided here, like Q1, here charge Q2 will go. So total charge is equal to, if you want to find, then we have formula Q total is equal to C equivalent into V total.
Yes, sir.
So Q total I am representing with Q. C equivalent we have 15 into 10 to the power minus 6, and V total, what is the total voltage? 10.
10.
This will become 150 into 10 to the power minus 6 coulomb. Or you can also write this 150 microcoulomb. For the third part, charge stored in each capacitor means Q1 and Q2. Charge stored in capacitor 1, Q is equal to C1 into V1.
Yes, sir.
Q1 is equal to C1 into V1. What is value of C1? C1 is 5 into 10 to the power minus 6.
Minus 6.
And what is the value of V1? V1 is again V1. Here the V1 is equal to V. Here is voltage V, that is equal to V1. Here is voltage. In this V2 is equal to V. Okay. The
Yes, sir.
voltage here again is 10 volt. Here again is 10 volt. So V1 is equal to 10 volt, because in the parallel combination this is 10. So this will become 50 into 10 to the power minus 6 coulomb, or you can write it 50 micro coulomb. And Q2 is equal to, you can write C2 into V2, and this will become C2 into V, and this will become C2 is 10 into 10 to the power minus 6, V is 10, this will become 100. 100 into 10 to the power minus 6 farad, or you can write this 100 microcoulomb, not farad. The unit
Yes,
of
sir.
charge is coulomb. You can write it. You can write here coulomb. And the fourth part is voltage across each capacitor. So what is the answer of this? V1 voltage across each capacitor. What is the value of V1?
So
What is the
V1 is
value of yeah. V1 is, see here, see the diagram.
just yeah 10.
This is
That's
this is
total
parallel.
volts. Yeah.
This is parallel combination. Here voltage
Yes,
will not
sir.
change.
Yeah.
So
So it will
V1
same.
and
It will be
V2, it will be
10
10 volts
volts.
again.
10 volts, right?
10 volts. Fifth part is fourth voltage. Total voltage. Total voltage. Tell me the total voltage.
So it will be 10.
Actually, your voice is lagging.
So it will be 10, sir.
Yeah, very good. Why you have not added this time V1 plus V2?
Sir, it will be same, right?
Yeah. But someone can think that V is equal to V total is equal to V1 plus V2.
No, sir. In the figure
Then he
itself,
can write
it's 10.
10 plus 10 and
How
21,
can
and
it
this
be
is
20?
and I will give the, if I am the examiner, I will give the minus 100 marks for this.
Yes, sir.
So V total is Vt, and this will become 10 volts.
Yes, sir.
Sixth part is energy stored in each capacitor. Energy stored in each capacitor. For the energy stored, we have formula.
Half
Energy stored in
CV,
capacitor,
half
half
C1
C1 into
V.
V1 square.
Yeah,
V1
means V
square.
only 10.
Yeah. Half the value of C1 is 5
5
into
into
10
10
to the
raised to
power
minus
minus
6 into 10
into
whole square.
10 square. So this will become half into 5 into 10 to the power minus 6. This will become 100. So you can write this is 10 to the power 5, 2.5. This will become 2.5 when you divide this.
Yes,
This will
sir.
become 2.5 into 10 to the power minus 4 joule. For U2,
Half
half
C1,
C2
C1, V1 whole square. V2,
to
yeah,
V2,
V whole
C2.
square.
Value of C2 is 10 into 10 to the power minus 6
Minus 6.
into 10 square. This will become
5,
this will
no,
be
yeah.
5. You are
5
right. 5
into
into 10.
10 raised to minus 4, yeah, joule.
This is the, and if I want to calculate the total energy,
Sir, I will add this, sir. Or you
yeah,
will do the
what?
formula half CV square.
Very good, very good. So I want to find UT total energy. Either
It will be U1
I
plus
will
U2
do
or a
this,
half CV square.
so I can write like this: 2.5 into 10 to the power minus 4 plus
Plus
5 into 10 to the power minus 4. This will become 7.5
7.5
into
into 10 raised to power minus 4 joule.
and joule. Or you can calculate the total energy from half C equivalent into
V square.
V square, V total square, and half C equivalent we have 15 microfarad.
Yes, sir.
See here, 15 microfarad. And what is that? V total means 10 square.
Yes, sir.
So now calculate this. This will become 15 by 2 will become 7.5
7.5
and 10 to the
into
minus
10
4.
to the
The
power
answer
minus
is
4.
so answer is same.
Yes, sir.
So have you written or do you want to note it down?
Sir, I want to write it, sir.
Okay, please write.
Sir, can you scroll up to the questions?
Yeah, yeah. Okay, no problem. Right. So this was the parallel combination. So in
Sir,
the
in the
next
figure
class,
you have written Coulomb and Farad, sir.
oh sorry. You can change it.
Yeah, it should be Farad.
Actually, you are a good student. This is microfarad.
Yes, sir. So you can scroll down
Yeah.
to the questions.
So we will have in the next class, I will finish this chapter in 45 minutes. And
Yes,
after the
sir.
45 minutes, maybe after the 45 minutes, maybe we will start very easy chapter current electricity. Very easy.
Easy.
Yeah.
Okay.
If you compare the two chapters like electrostatic potential and capacitance or electrostatics, if you compare the electrostatics from the current electricity, then I think electrostatics is little bit more difficult than the current electricity, because in the electrostatics there are the vector additions and all that.
Yes,
Uh,
sir.
As compared to, there are more vector additions as compared to current electricity, and there are the integration, more integrate. You have to integrate more in the chapter electrostatics, in the unit electrostatics.
Yes,
So
sir.
that's why I'm saying actually the student feel difficulties when that when things become variable, when things become variables. So
Sir,
for
can you?
example, yeah.
Yes, sir. Yes, sir.
For example, if I am giving you a point charge, then you can calculate the electric field easily at a point. If I am giving a rod, if I am giving a rod having a positive charge of Q, then
Yes.
this will be difficult for you because you have to integrate that at that time.
Yes, sir. Sir, can you scroll down?
Hmm. So in the next class, we will solve some good numericals of on the parallel and series combination.
Yes,
And
sir.
after that, we have one very small topic. What what I will do for a parallel plate capacitor, I will divide the capacitor into different dielectric. Means I will fill the dielectric in the space of the capacitor, in between the space of the capacitor, different dielectrics, and due to that, the capacitance of the capacitor will change.
Yes, sir.
That will be the in that there is also a series and parallel combination, and that topic is for we will study about 15 to 20 minutes, and after
Sir, can you
that
scroll
will
down?
be completed.
Yes, sir.
The parallel combination, in parallel combination, the positive plate of the capacitor is connected to the positive plate
Positive
of
plate
the
of the other capacitor.
another capacitor, and negative plate is connected to the negative
The
plate of
negative
another
plate.
capacitor.
Sir, can you scroll down?
Have you heard about flash?
Flash. Yes, sir. The hero, right?
Hmm?
Flash, the guy from DC, right?
Yeah. Have you seen Justice League?
No, sir.
Very good. And please revise your notes,
Yes, sir.
because the primary thing for you is to study your notes. Study. All other things are secondary.
So can you scroll down? Done, sir.
Okay, Harsh, that's all for today. And please
Okay,
revise
sir.
your notes.
Yes, sir.
And we will finish this chapter in the next class.
Okay, sir.
In 45 minutes or 50 minutes, I will finish this chapter. Okay,
Okay,
now
sir.
Harsh, you can do it.
Okay. Thank you, sir. Bye, sir.